Download this code from codegive.com, link in the description below. OK, let's dive into troubleshooting 101 for anylogic models. This comprehensive guide will walk you through common error types, debugging techniques, and best practices to help you build robust and reliable simulations. We'll also include code examples to illustrate the points. Understanding the landscape, types of errors in anylogic. Before we start debugging, it's crucial to know the types of errors you'll likely encounter. 1. Compilation errors, syntax errors. These are the most basic errors, detected by the anylogic compiler before you even run the simulation. They are usually due to typos, incorrect grammar, syntax, in Java or anylogic's expression language, or missing components. The error message will tell you the line number and a description of the problem. 2. Runtime errors, exceptions. These errors occur during the simulation run. They are often caused by unexpected conditions like dividing by zero, trying to access an element outside the bounds of an array, or other logical problems. Runtime errors will typically stop the simulation and provide an exception message. 3. Logical errors *. These are the trickiest to find because the simulation runs without crashing, but the results are not what you expect. They can stem from incorrect formulas, flaws in the model's logic, incorrect parameter values, or a misunderstanding of the system you are simulating. 4. Data errors *. Problems arising from the input data you're using in your model. These might include incorrect data formats, missing values, or data that falls outside expected ranges. They can lead to both runtime and logical errors. 2. Tools of the trade, debugging techniques in anylogic. Anylogic offers a set of features designed to help you pinpoint and fix errors. 1. The error panel *. The error panel in anylogic is your first line of defense. It lists all compilation errors and runtime exceptions. Double-clicking on an error message in the error panel will take you directly to the line of code where the error occurred. 2. The debugger *. The debugger is a powerful tool that allows you to step through your simulation code line by line, inspect variable values, and set breakpoints, locations where the simulation will pause. Breakpoints *. Place breakpoints in your code at strategic locations, example before or after a critical calculation, inside a loop, at the entry point of a state chart. When the simulation reaches a breakpoint, it pauses, giving you time to examine the state of the model. Stepping *. The debugger provides step over, step into, and step out commands. Step over * executes the current line of code but skips over method calls, executes the entire method without stepping through it. Step into * executes the current line of code and enters the method being called, if there is one. Step out * finishes executing the current method and returns to the calling method. Variable inspection * While the simulation is paused at a breakpoint, you can inspect the values of variables in the variables view, usually docked at the bottom of the anylogic IDE. This is essential for understanding what's happening in your model. Expressions * You can evaluate arbitrary Java expressions while debugging by adding them to the expressions list. This allows you to see intermediate results. Conditional breakpoints * set breakpoints that only trigger when a specific condition is met. For example, you can set a breakpoint to stop only when a certain variable exceeds a threshold. This can be highly useful for isolating the root cause of problems in complex simulations. 3. Console output, prints adding system.out.println, statements to your code is a simple but effective way to print values of variables or messages to the console during the simulation. This can help you trace the flow of execution and identify unexpected results. Remember to remove or comment out these prints once debugging is complete to avoid cluttering the console in production. For animation and visualization *, watching your simulation's animation can reveal logical errors that are not immediately obvious from the code. Pay attention to how agents are moving, interacting, and changing their states. Anylogic's charting capabilities allow you to visualize key metrics and identify trends or anomalies that might indicate a problem. 5. Logging * Implementing a robust logging system can be invaluable for debugging and monitoring your simulation, especially for long-running or complex models. Anylogic integrates with Java's logging framework, allowing you to record events, variable values, and other relevant information to a file. 6. Unit testing * Testing individual components of your model, example functions, state charts, agent types, in isolation can help you catch errors early and ensure that each component is working correctly before integrating it into the larger simulation. 3. Common error scenarios and solutions, with code examples. Let's go through some common error scenarios and how to troubleshoot them, complete with illustrative code. 1. Compilation error, incorrect syntax. Scenario * You misspell a keyword or use incorrect syntax in your Java code or anylogic expression. Example Troubleshooting The error panel will highlight the line with the syntax error. Read the error message carefully, it will usually tell you what's wrong, example expected. 2. Runtime error, null pointer exception. Scenario * You try to access a field or method of an object that is null, i.e., it doesn't exist. Example Troubleshooting 1. Use the debugger. Set a breakpoint before the line that's causing the null pointer exception. 2. Inspect the value of my agent. Is it actually null? 3. If it's null, trace back in your code to find out why it's null. Did you forget to create the object? Was it set to null by mistake? Solution Or, defensively. 3. Runtime error, index out of bounds exception. Scenario You try to access an element of an array or list using an index that is outside the valid range of indices. Example Troubleshooting 1. Use the debugger. 2. Inspect the size of the array or list. 3. Inspect the value of the index you're using. Is it less than 0 or greater than or equal to the size of the array/list? Solution Ensure your index is within bounds. 4. Logical error, incorrect formula or algorithm. Scenario Your simulation runs without errors, but the results are not what you expect. This is often due to a mistake in a formula or algorithm. Example You want to calculate the average waiting time of customers in a queue, but you use the wrong formula. Troubleshooting 1. Review your formulas * Carefully check the formulas you're using against the actual mathematical relationships in the system you're modeling. Double check units. 2. Console prints * add system.out.println, statements to print intermediate values at various points in your calculation. This can help you see where the results start to diverge from what you expect. 3. Unit tests * If possible, create unit tests to verify that individual functions or calculations are working correctly. 4. Compare to reality * If you have real-world data for the system you're modeling, compare the simulation results to the real data. If there's a significant discrepancy, it likely indicates a logical error. Example, illustrative. 5. Data error, invalid input data. Asterisk scenario asterisk your model is using data that is in the wrong format, contains missing values, or is outside the expected range. Asterisk example asterisk you're reading data from a CSV file, and one of the columns is supposed to contain integer values, but it contains text. Asterisk troubleshooting asterisk. 1. Validate input data asterisk before using the data in your model, add checks to ensure that it is in the correct format and within the expected range. 2. Handle missing values asterisk decide how to handle missing values. You can replace them with the default value, skip the data point, or raise an error. 3. Log invalid data asterisk if you encounter invalid data, log it to a file or the console so you can investigate the source of the data problem. Asterisk example, illustrative. 4. General debugging tips and best practices. Asterisk start small asterisk build your model in small, incremental steps. Test each component as you add it to ensure that it's working correctly. Asterisk write clear, well-documented code asterisk use meaningful variable names, add comments to explain complex logic, and follow consistent coding conventions. This will make it easier to understand and debug your code later. Asterisk version control asterisk use a version control system, like Git, to track changes to your model. This will allow you to easily revert to a previous version if you introduce an error. Asterisk simplify the model asterisk if you're having trouble debugging a complex model, try simplifying it by removing unnecessary components or reducing the number of agents. This can help you isolate the source of the problem. Asterisk reproduce the error asterisk make sure you can reliably reproduce the error before trying to fix it. This will help you confirm that your fix actually solves the problem. Asterisk take breaks asterisk if you're stuck on a problem, take a break and come back to it later with a fresh perspective. Asterisk ask for help asterisk if you're still struggling to debug your model, don't hesitate to ask for help from the anylogic community or a colleague. Asterisk understand the anylogic documentation asterisk the anylogic documentation is comprehensive. Use it. V example, debugging an inventory management model. Let's put these principles into practice with a simplified example of an inventory management model. Assume we have a simple system where we order stock when the inventory level drops below a reorder point. Possible errors and debugging asterisk. 1. Logical error, inventory never goes below reorder point. Asterisk symptom asterisk you expect the order more function to be called, but it never is. Asterisk debugging asterisk. Asterisk add a print statement in the process demand function before the if statement, system.out.println, inventory, plus inventory level plus, reorder point, plus reorder point. Asterisk check the values of inventory level and reorder point. Are they what you expect? Is the demand high enough to cause the inventory to drop below the reorder point? Asterisk consider changing the create_recurring_event to increase the demand size create_recurring_event, 1, product process demand, 50. 2. Runtime error, negative inventory. Asterisk symptom asterisk the inventory level becomes negative. Asterisk debugging asterisk. Asterisk add a breakpoint before the inventory level dash equals demand, line in the process demand function. Asterisk inspect the values of inventory level and demand. Is demand larger than inventory level? Asterisk solution asterisk add a check to prevent negative inventory. 3. Logical error, order quantity too small, leading to frequent reorders. Asterisk symptom asterisk you see the order more function being called very frequently, even though the demand isn't that high. Asterisk debugging asterisk. Asterisk look at the code and think through the replenishment cycle. Is the order quantity large enough to cover the demand during the lead time? Asterisk adjust the parameters, increase the order quantity or decrease the lead time to see if it improves the situation. 6. Beyond the basics asterisk advanced techniques. Asterisk profiling asterisk if your simulation is running slowly, use a profiler to identify the parts of your code that are taking the most time. AnyLogic integrates with Java profilers. Asterisk memory management asterisk for large-scale simulations, pay attention to memory management. Avoid creating unnecessary objects and release resources when you're finished with them. Use AnyLogic's dispose method. Asterisk parameter sensitivity analysis asterisk use AnyLogic's built-in experiment types to test how sensitive your model is to changes in parameter values. This can help you identify potential weaknesses in your model and areas where you need to be more careful about parameter selection. This tutorial provides a strong foundation for troubleshooting AnyLogic models. Remember that debugging is an iterative process. Be patient, methodical, and persistent, and you'll become proficient at finding and fixing errors in your simulations. Good luck.